This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. So I already made a video about how to make fuming nitric acid. This time my yield in the first video was about 50%. This time it's going to be about 93% or 95% or something like that. I got a 2,000 milliliter round bottom flask with some stir rods in there as boiling stones. I'm going to add into it 303 grams of potassium nitrate, stump remover. Alright, there's my apparatus. You see over there I got the potassium nitrate, a Vigorix column. The only reason I have a Vigorix column, now we gotta get better separation. Right now I have a funnel up here because I still have to add the sulfuric acid. That's how I'm going to add it. I got a little tiny condenser, comes down here to the receiving flask. And you can see this hose comes down to here and into this little round bottom flask thingy. It comes out. That's a suck back trap. And it goes around to the back there. I don't know if you can see that. But there's a right there. There's a little bubbler there with some sodium hydroxide in it. I don't know if you can see it back there. Basically, when I add the sulfuric acid, it's going to react and make nitric acid, and I'm just going to distill it out. That's it. So I'm just going to add about 170 milliliters, 168 milliliters of this acid here, drain cleaners. You can see it's starting to get up to all the gases coming out. Going all the way up there, it's even getting into the condenser and stuff. So I'll be distilling here in a second. It's 83 degrees I want to hit it at. That gas will subside soon. I mean, it won't be as bad once it starts distilling. There's a receiving flask. You can see it's starting to come over. Hopefully after it starts distilling a little bit, some of this gas will go away. You can see in the condenser it's not that bad anymore. Steelhead's still bad. Bubbler's going back there, it's still good. This is the suck back trap for the bubbler, and you can see there's no gas in it yet. Steelhead's actually about 80 degrees right now. And it's going to slowly go up to 83. It's coming over right now, though. And you can see the more I distill, the less CO2 I have. I mean, the less NO gases, nitrogen oxide gases I have in the apparatus. See how the bend here is gone. There's nothing in the condenser. Still, it somewhat has a little bit, but you can see it's cleared up a lot. Still some up there. So that's a good sign, and it's on its way. All I gotta do is wait. I mean, it's that easy. You want to make an acid, you usually get the salt of the acid you want. I got potassium nitrate because I want nitric acid. And I dripped a stronger acid on it. In this case, I chose sulfuric acid. Now it does produce gases, nitrogen oxide gases. It's really not that bad. I have a fan in the window, and that's pretty much it. And once it cools down, like right now, where there's not that many gases, you know, it's not that bad. Definitely, if you have a fume hood, use it. See, the gases in the Vigrex column are gone. Alright, so I'm done. There's the receiving flask. I did add in an extra 30 milliliters of sulfuric acid. That's another half a mole. I just wanted to see, because I already know the percentages, you know, the 270. So I threw, because the way I'm getting a better yield, like from my other videos, my last one, I only got 50%. Now I'm getting like 95, 96 or whatever, 94. I don't know. I got to look there. But anyways, is by adding more sulfuric acid. So I figured, well, maybe if I add a little bit more, let's see what happens. Do I still just get the 95%, or does it go up to 100%? Well, we'll see in a second here. There's the equation at top. Sulfuric acid plus potassium nitrate makes nitric acid and potassium bisulfate. Here's your molar masses and molar volumes. I'm just guessing, I put 95% sulfuric acid, so I divided so I can get how many milliliters I need out of the bottle to get this much sulfuric acid. It'd be 56 milliliters. Now in the first video where I only got 50%, I did a 1-to-1 ratio, okay? That only got me 50%. Now look at this new ratio. Now the new ratio that I do, and I get 93% pretty much every time. Instead of a 1-to-1 ratio, I'm using a 1.5-to-1 ratio. So instead of every 101 grams of potassium nitrate, instead of adding 56 milliliters of sulfuric acid, I add 84 milliliters. And that makes all the difference to double your yield almost. Because I used to get 50, now 93. That's almost double. The question is, will more sulfuric acid help you get more than 93%? And I actually wanted to do that on this experiment in this video, but I kind of messed up. But this is the ratio. If you want 93% yield, that's what you do. Every 101 grams, put 84 milliliters. That's a pretty good jump from 50 to 93. That's my best jump ever. Now, unfortunately, what I did in the video, what I wanted to do was add, you know, 2 moles of sulfuric acid to 1 mole of potassium nitrate and see if I got 100%. You know what I mean? Unfortunately, what I did was I figured it out, 3 moles of that and 3 moles of that, which is a 1-to-1 ratio. That's what I was doing originally. Listen, I want you to keep in mind I made a little typo here. This 2 should be a 1. 168, not 268 milliliters. Because 56 times 3 is 150 plus 18, 168. And I put in 303 grams and 268 milliliters. Not thinking I'm supposed to add in more. In the middle of the distillation, you know, when I was doing this, I was like, wait, I want to see what happens if I add even more sulfuric acid in. So I stopped the distillation. I added 30 more milliliters, a half a mole. Not realizing I never figured it out. I was still doing a 1-to-1 ratio. Um, so anyways, halfway in, I threw in 30 milliliters. Now, if you think about it, a 1-to-1 ratio, a 1 to 1.5 ratio would mean I would need 3 moles of potassium nitrate, and I would need 1.5 times that 3 moles. So 1.5 times 3 is 4.5 moles. I only put 3 moles in. I should have put another 1.5 moles in just to get the 93%, right? Now 1.5 times a mole, that's a mole of sulfuric acid, that's 84 milliliters. So just to get the 93%, I needed to add in additional 84 milliliters of sulfuric acid for this. I added in 30, thinking I already added it in, right? Thinking, oh, I'll figure out what happens if I put even more acid in. I never put the 84 in the get-go, okay? I only put 30 in, and therefore I didn't even figure out how much I have there. I know it's not 93%, although it might be 90% or something, 85. But I didn't put all the acid in that I needed. That's another 54 milliliters I should have added, you know what I mean? And I didn't. So if you keep to the ratio, 1 mole of potassium nitrate to 1.5 moles of sulfuric acid, you'll get 93%. Now, if you add even more sulfuric acid, you might get more than 93%. You might get 95, 96, 97. I don't know. I wanted to see with this video, but as you can see, I made the mistake. So my suggestion, if you're going to try to make this or whatever, maybe add 2 moles of sulfuric acid in and 1 mole of nitric acid and see if you get even better than 93% yield. You know what I mean? My thoughts are is if you add enough sulfuric acid, you'll get 100% yield. I mean, you think about it, the sulfuric acid that's left is tiny bit, and at the end of the reaction, and the potassium nitrate is a tiny bit there. You know what I mean? They have to touch each other. They can't just be in the same reaction plot. So at the end, if you have a lot of excess sulfuric acid, you have more of a chance for it to find the remaining few molecules of potassium nitrate to give you that higher yield. All right, so here it is. It's a 150 milliliter flask. So if you want to learn anything about like the difference between this is red fuming nitric acid. If you want white fuming nitric acid, you have to almost distill it or put a big vacuum on it to just get rid of the NO gases so it's clear. That's the only difference really. I like the NO gases to stay in there because if I add water, those NO2 gases turn into acid. So I feel like I'm just burning away my acids if I put it on a vacuum. But if you want to know about the differences and a little bit more facts on nitric acid, go to the original video I made on making fuming red nitric acid. There's a lot of info in it, even though I only got a 50% yield. The rest of the information is good. And also you can see how it's different from this. That was a 50% yield. This is a 93% yield. And you all have a great day, and always remember, science is great.